Hi everyone. In this class, we are going to discuss about design of flat belts. So at the end of this class, you will be able to solve flat belt problems. So let us see one example. A flat belt running on a pulley of diameter 1.2 meters transmits 9.5 kilowatts at 240 rpm and mu is equal to 0.3. Here mu means coefficient of friction between belt and pulley, and the diameter of smaller pulley is 225 mm and center distance is equal to 1.5 meters. Find the necessary width of the belt if the pull should not exceed 20 newtons per mm. So here we have to make a small correction. So here, if the pull should not exceed 20 Newton per mm width, 20 Newton per mm width, we have to make a correction here. Here width is missing. 20 Newton per mm width. Ikkada width ivvali actual ga. Okay na? So it's not 20 Newton per mm. 20 Newton per mm width. Mm width. Neglect centrifugal tension. Neglect centrifugal tension. Okay. This is flat belt problem. So there is a flat belt running on a pulley of diameter 1.2 meters. So given a diameter of larger pulley. So first of all, let us list out given data. So based on the given data, we can solve this problem. So first of all, diameter of larger pulley. Diameter of larger pulley D1. Let us say D1. D1 is equal to 1.2 meters. D1 is equals to 1.2 meters. Next. Transmits 9.5 kilowatt. So given power. So here it can transmit power transmitted by belt. Power transmitted by belt. Given power transmitted. How much power transmitted by the belt? Power transmitted by the belt. So power transmitted by the belt, capital P is equal to 9.5 kilowatts. Okay. So kilo means 1000. So capital P is equal to 9.5 into 10 cube watts. So you will get 9500 watts. 9500 watts. So this much power transmitted by the belt. And next, given speed. So speed N is equals to 240 rpm. 240 rpm revolutions per minute. So at the same time, and given coefficient of friction. Coefficient of friction. Mu is equal to between pulley and belt. Coefficient of friction between pulley and belt is mu is equal to 0.3 given. Okay, 0.3. Diameter of smaller pulley is 225 mm and given diameter of smaller pulley. Diameter of smaller pulley. So diameter of smaller pulley D2. Let us say D2. Okay, no? So D2 is equal to 225 mm. 225 mm. So D2 is equal to 1 mm is equal to 1 by 1000 meters. 1 mm is equal to 1 by 1000 meters. 220 by 1000 means 0.225 meters. 0.225 meters. Okay. Next. So next given center distance. So center distance. So let us say center distance is equal to x. X is equal to how much? Center distance. Given center distance 1.5 meters. 1.5 meters. So distance between centers of larger pulley and smaller pulley is 1.5 meters. Okay. Find the necessary width of the belt if the pull should not exceed. So maximum pull, maximum pull. So maximum T max, maximum pull is equal to, so 20 newtons, maximum pull is equal to how much? 20 newtons per mm width, per mm width of the belt, per mm width of the belt. Okay. So at last here our objective is to find width of the belt. At last we need only one parameter, that is width. So W, small w. So using this data we have to design a flat belt and we have to find width of the belt. W కావాలి మనకి. Ultimate గా ఈ ప్రాబ్లం లో మనం find out చేయాల్సింది W. Find width of the flat belt. Okay. Let's solve this problem. Using this data, let us calculate width of the belt. First of all, let us draw a rough sketch of a flat belt. This is larger pulley and this is smaller pulley, and there is a flat belt around larger pulley and smaller pulley, and this is diameter of larger pulley D1 and diameter of smaller pulley D2. Suppose let us assume here the drive, this is called larger pulley, this is called, suppose this is a driving pulley, means this is driven pulley, and here the driving pulley rotating in clockwise direction, and this side is called slack side, and this side of belt is called tight side. Okay. So here we have two types of tensions. In any flat belt we have two types of tensions. T1, here T1 means T1, T2. So T1 means tension in the tight side of the belt, and T2 means tension in the slack side of the belt, the slack side of the belt. Tension. Anyhow, we need width of the belt. At last, we need width of the belt. So small w, we have to calculate small w. And here important information is, the given maximum tension is equal to, or maximum pull. So maximum tension or maximum pull should not be exceed 20 newtons per mm width, per mm width of belt, per mm width of belt, per mm width of belt. So given maximum tension per mm width of belt 20 newtons. So maximum tension is 20 newtons per mm width of belt. Now, so we know that per mm width of belt maximum tension is 20 newtons. Okay. Here we don't know what is the maximum tension in the belt. Maximum tension in the belt. So, in case of flat belt drive, if suppose if centrifugal tension is negligible, then T1 is the maximum tension in the belt in newtons. See, in case of open belt drive or flat belt drive, suppose he didn't mention anything about centrifugal tension, so or otherwise suppose he clearly given consider negligible centrifugal tension, then maximum tension in the belt is T1. Okay, and T2 is the minimum tension. So T1 is the maximum tension in the belt. If we calculate maximum tension in the belt, then we can calculate width of the belt. So for width of the belt, 20 newtons is the maximum tension. Okay. Now, what is the formula for width of the belt now? So we have T maximum, T1. Width of the belt. Width of the belt. So width of the belt allows W is equal to. So for width of the belt, for 1 width of the belt, maximum tension is 20 newtons. So for T1 newtons, what is the width of the belt? So W width of the belt is equal to T1 by T max. T1 by T max. Okay. So using this formula, we can find width of the belt. So మనకి ఇప్పుడు width of the belt కావాలంటే T1 కావాలి. ఎందుకు width of the belt is equal to T1 by T maximum. T1 means maximum tension in the belt in newtons. T maximum means maximum pull or maximum tension in the belt per width of belt. Per 1 కి ఇంత టెన్షన్ అనేది ఉండాలి బెల్ట్ కి. ఓకేనా, మాక్సిమం టెన్షన్ బెల్ట్ కి ఎంత పర్ విడ్త్ కి 20 న్యూటన్స్. ఓకేనా, మరి విడ్త్ టోటల్ విడ్త్ ఆఫ్ ద బెల్ట్ కావాలి నాకు. సో అప్పుడు మనం ఏం చేస్తాం, మాక్సిమం టెన్షన్ ఇన్ ద బెల్ట్ బై మాక్సిమం టెన్షన్ పర్ విడ్త్ ఆఫ్ బెల్ట్. ఓకే, సో అట్ లాస్ట్ ఎనీహౌ we need T1. If we calculate T1, then we will get the answer. So T1 వస్తే ఇది వచ్చేస్తుంది, W వచ్చేస్తుంది. ఓకే, సో ఫస్ట్ T1 ఫైండ్ అవుట్ చేద్దాం. So in flat belts, we have some formulas like T1 by T2 is equal to ratio of tensions. T1 by T2 is equal to e power mu theta. T1 by T2 is equal to, first formula, T1 by T2 is equal to e power mu theta. So mu means coefficient of friction. T1 by T2 is equal to, given coefficient of friction as 0.3 into theta. So what is theta? Here theta is called angle of lap. Here theta is called angle of lap or angle of contact. Theta is called angle of contact. So here theta is called angle of lap or angle of contact. So what is angle of lap or angle of contact? So let us consider a pulley, driven pulley, and here C is center of the pulley. C is center of the pulley, and this is the belt wraps around it or wounded around it. So this is a portion of belt wraps around this pulley, and this is pulley and this is belt. Okay. This angle is called angle of contact. This angle is called angle of contact, and this angle is alpha, and this angle is alpha. Now, what is angle of contact or angle of lap? The angle formed at center of a pulley. The angle formed at center of a pulley by a portion of belt wraps around it. So wraps around the pulley is called angle of contact. The angle formed at center of the pulley by the portion of belt wraps around this pulley is called angle of contact or angle of lap. Now angle of contact formula, theta is equal to 180 degrees minus 2 alpha, 180 degrees. So this is straight angle, say this is complete angle. So straight angle means 180. Okay, so 180 minus alpha plus alpha, 2 alpha. We need this angle theta. 180 minus 2 alpha by into pi by 180 radians. So 180 minus 2 alpha in degrees. Suppose we want theta in radians, then this is the formula. Here alpha is given by here alpha is equal to sine inverse of d1 minus d2 by 2x. d1 minus d2 by 2x, or one more formula is there, or sine inverse of in terms of radii r1 minus r2 by x. Here what is x, what is d1? diameter of larger pulley. D2, diameter of smaller pulley. What is X? Distance between two pulleys. Distance between centers of two pulleys. Sorry, distance between centers of two pulleys. And here R1 and R2, radius of larger pulley, and R2 is radius of smaller pulley. So let us find alpha first of all. To get theta, to find theta, we need alpha first of all. First alpha find out shall we? Okay, na? Once we get theta means we can find T1 by T2 ratio. Okay. So alpha is equal to sine of R1. R1 means radius of first of all let us find R1 and R2. R1 is radius of larger pulley. Radius is equal to half of the diameter D1 by 2. D1 how much? 1.2 by 2. 1.2 meters D1. Diameter of larger pulley. You will get 0.6 meters. And what about R2? R2 is equal to radius of smaller pulley. So radius of smaller pulley is equal to half of the diameter of smaller pulley. D2 by 2. D2 how much? 0.225 by 2. 0.225 by 2 means 0.1125 meters. 0.1125 meters. X is equal to how much? Given distance between centers of two pulleys is 1.5 meters. Okay. Next. Now alpha is equal to, now substitute all the values, sine inverse of 0.6 R1 minus R2, 0.1125 by 1.5. First of all find alpha. Alpha is equal to sine inverse of 0.6 minus 0.1125 by 1.5. If you calculate, you will get 0.325 here. 0.325. Now simplify this. So alpha is equal to sine inverse of 0.325 is equal to, you will get 18 point, here I got 18.97 degrees. So alpha is equal to 18.97 degrees. Now just plug in alpha is equal to 18.97 in theta. You will get theta value. So in this formula, you will get theta value. We have got alpha is equal to 18.97 degrees. Let us plug in this alpha value in theta formula. You will get theta, angle of contact. Theta is equal to 180 degrees minus 2 into alpha, 18.97 degrees, into pi by 180 radians. Okay, anyhow, units in radians. So theta is equal to, so if you calculate this value, you will get approximately you will get 2.48 radians. Angle of contact theta is equal to 2.48 radians. Okay. Now we have angle of contact. Now we can find ratio of tensions. T1 by T2 is equal to E power mu value, coefficient of friction 0.3 into theta 2.4. Now T1 by T2 is equal to, if you calculate, you will get approximately 2.1043. T1 by T2 is equal to 2.1043. Now from this equation, transpose T2, you will get T1 is equal to 2.1043 into T2. Now transpose 2.1043, multiplication becomes division. Now T2 is equal to T1 by 2.1043. T1 by 2.1043. Let it be equation number 1. Okay, na? So then equation number 1 next. We have one more relation for T1 and T2. So that is power transmitted by the belt. Power transmitted by a belt. Capital P is equal to difference between tensions T1 minus T2 into V. Here V is velocity of the belt. Here V is velocity of the belt in meter per second. So what is the formula for V? V is equal to pi d n by 60. Pi d1 n by 60. So here d1 means diameter of larger pulley. Diameter of larger pulley in meters. N is a rotational speed. V is equal to pi into diameter how much? 1.2 meters into speed. Speed is given 240 rpm by 60. 61 so 64. 1.2 into 4, 4.8. So 4.8 pi meters per second. Therefore, velocity of the belt in meters per second is 4.8 pi. So V is equal to 4.8 pi, and power is already given. So power transmitted by the belt, how much is given? 9.5 kilowatts. So in watts, 9,500 watts. Now we can find T1 minus T2 from this formula. T1 minus T2 is equal to P by transpose V, P by V. Okay, now we have P value 9,500 watts and V value 4.8 pi. Now we will get one more relation in terms of T1 and T2. Okay. Okay. So power transmitted by a belt, P is equal to T1 minus T2 into V. Now transpose V. Then T1 minus T2 is equal to what? T1 minus T2 is equal to T1 minus T2 is equal to P divided by V. Multiplication becomes division. Now T1 minus T2 is equal to P how much? 9,500 watts by V 4.8 pi. V value 4.8 pi. Now T1 minus T2. So if you simplify this, you will get approximately 630. T1 minus T2 is equal to 630 newtons. Tension units in newtons. Let it be equation number 2. Okay. So anyhow, here we need maximum tension T1. This is maximum tension in the belt. Maximum tension. So here we should eliminate T2. Okay, now we have to eliminate T2. Then only we will get T1. So from equation 1, what is T2? T2. Okay, now substitute T2. Substitute T2 is equal to T1 by 2.1043 in equation 2. So this is equation 2. So T2 in terms of T1 is T2 is equal to T1 by 2.1043. So we are eliminating T2. So T1 minus, what is T2? T1 by 2.1043 is equal to 630. So take out T1. So T1 is common factor, 1 minus T1 common, and here we can write 1 minus 1 by 2.1042 is equal to 630. Okay. T1 into 1 minus 1 by 2.1043. This value is 0. You will get 0.4752. This value is 0.4752 is equal to 630. T1 into 1 minus 0.4752 means you will get 0.5248 is equal to 630. Now T1 is equal to, transpose this, you will get 630 by 0.5248. Okay. So if you calculate, you will get tension, maximum tension as 1200.4, approximately 1200.4 newtons. Okay. So now we have got T1. Now width of the belt W is equal to T1 by T max. Okay. So T1 means maximum tension how much? 1200.4 newtons by T max means maximum tension in the belt per mm width of belt. Okay. So if you calculate, approximately you will get width of the belt as 60 mm. Approximately 60 mm. So width of the belt is 60 mm.